Star Wars. May the Fourth be with you coming up. Hurry, Chewbacca. We're being attacked by the Death Star. It's too late, kid. We're finished. No! Yeah, welcome back. Newbold. Videos. Logarithm. Story time. Whoa. Star Wars. Alright, thanks for watching. So, we're helping you today with graphing logarithms. And so this will be like exponentials, but increasing at a decreasing rate. And so some examples, you'll just be doing problems 1 through 6 for this at-home learning. If we're back at school, then you'll probably have quite a few more problems, but that's okay because we'll help you in class with them as well. Nice, nice, nice. And so let's just jump right into it. So what does the graph of a logarithm even look like? Well, if you have your graphing calculator, then you can go ahead and view a large calculator. Oh, I don't know. I think I've already got it on large. Oh, there you go. Large. That didn't even change. Okay, so you go to y equals, and you just type log of x. And let's take a look and just inspect what it looks like. Cool. There it is. Look at that. Nice. And so that just kind of starts here. Starts off at 0. Oh, nothing at 0. So log of 0 is nothing. And that's why you can't have log of a negative number. And so as we go to the right, it slowly increases. But just at a pretty steady pace. Just growing, but not super fast. At 6 at 7. Just for curiosity's sake, if we go, I don't know, like all the way to 100, then what would that look like? Would we even surpass 10? Let's take a look. Slowly, ever so slowly growing at a decreasing rate. Okay, well there you go. So that is what log looks like. So I'm going to push zoom and then 6, zoom 6. That gives us the 10 by 10 graph again. Awesome. So if we take a look at our table, because that's what we use to plot on our graph, this is what it looks like. Nice. Okay, so if we're going to graph this, we would go ahead and we would start off at, let's see, so not at 0, because that's an error, but over 1 up 0. Good, over 1 up 0, so that's here. And then we did start down here a little bit. I wonder, do you know, where is the actual starting point? Can we even see it? That's interesting. So let's go ahead and zoom in now. Instead of zooming out, let's go ahead and zoom in. And let's see where log even starts. Ooh, you see how it's going downwards? That's interesting. So I wonder how much downwards. Well, in this case, it says 0.03. We go down negative 1.42. But what if we were to zoom in more? Well, if we were to zoom in more, you'd start to see that it actually gets really close to y equals 0, but never actually crosses it. Look at that. So it goes all the way down, getting really close to the y-axis. So it looks like there's an asymptote there that doesn't cross. Awesome. So then we can go ahead and use that to help us with our graph. Okay, so it looks like we're just doing a straight arrow downwards like this. Nice. And then we're coming up and hitting 1, 0. Sorry that I kind of crushed it there. And then, let's see, when do we, wow, we don't even hit 1. So now we're going to go all the way over to 6, and it goes up to 0.77, which is right about here. So what a crazy graph to graph. So here's our logarithms, just slowly increasing. And there it is. So there is y equals just log of x. Now when we say log of x, we actually mean base 10. So whenever there's just log, it's actually base 10 because we count on 10 fingers, 10 toes. So then, can you guess what log 10x plus 2 would look like? So that would just be a shift of, hopefully, up 2. I haven't really got into graphing logarithms too much, so that's what I'm guessing. So we'll go to y equals log base 10. And so just to show that to you, because some of you don't even believe that, I'm going to go to the math button and up to log base. That actually lets you choose your base. So, and you can show this on Desmos too for those of you who don't have Desmos. So log base 10 is just the same as log. And so we'll show you that right now, just so you can see they're exactly the same. Log base 10 is the same as just log. And then we'll go ahead and do, whatchamacallit, a zoom standard 10 by 10 graph there. There it is. So there's our log base 10x, and in red, there's our log 10x there. Cool. And if you still can't see it, because this is such a small screen, we'll go and zoom in a little. Okay, so there's our log x, and then our log base 10x. They're exact same graph. You can see the red and the blue. Just like Star Wars, blue lightsaber until the dark side takes over red. Cool. Okay, so then log base 2x, let's just see if that shifts it, but this time let's use Desmos. So Desmos is what some of you that don't have a graphing calculator at home will be using to do this assignment and on the quiz. Actually, I don't even know if we're going to have a log. I know we have exponential matching graphing, but I don't know if we're going to have a log graphing on the test for all the stuff we're learning. So that would be a good thing, but not necessarily. For those of you who want to show your knowledge on logs. So while looking around at Desmos, right, I found a little symbol down here, which is a keyboard. So if you click on Show Keyboard, and I don't see log anywhere, but if you go to Functions, still don't see log anywhere. But if you go to Miscellaneous, that's where we can find ln and log base, whatever. So let's just go ahead and do log. So log of x, close parenthesis, there it is. And now we're going to do the +2. And look at that, it shifted up 2. So it's still along here, but it's going to go ahead and hit at this point right here. And so that's going to be over 2. I wonder if we could show both. That'd be fun to see that shift, right? So again, you go to Functions, you go to Miscellaneous, you go to Log, and then we're going to do log x, close parenthesis, and then not plus anything, just log. Okay, so there it is. Yep, it shifted up 2. Every point shifted up 2. So the +2 on the outside is your shifter up or downer, right? Cool. Okay, so then what we'll do is we're going to shift all these points up 2. Nice. What's your favorite color? Green? Okay, we'll try green on this one. So now, instead of being here where it crosses, it's actually going to shift up 2, it looks like. Let's double check. So instead of crossing at 1, it's going to cross at over 1, 0. It's going to cross at over 1. And that's going to be over 1, up 2. Nice. Over 1, up 2. Okay, so now we're going to go over 1, up 2 is where it's going to cross. There we go. And so again, we have an arrow down here like this. And then we're going to go upwards. It's hard to do straight with the mouse. And then through there, and then along there. And there it is, shifted up 2. So the outside means to shift up 2. So then can you guess what the inside would be? That's right, shift left or right. Remember, it's opposite what you think. So let's take a look at 7, and let's see if we can guess, and then use our calculator and check and see if we got it right. So this one is saying to shift up 1 this time. So instead of shifting up 2, we're only going to shift up 1. But then, so that's up 1. What do you think this +1 inside the parenthesis means? Well, originally I usually think right 1, so it actually shift here. But because it's inside, let's type that out. Because it's inside the parentheses, it's easier just to put the symbols, parentheses, then it's opposite what you think, right? So instead of right 1, it's actually going to be right 1. Wait, instead of right 1, it's actually going to be left 1. There we go. Okay, awesome. So that means we're actually going to go back here 1. Interesting. So now we've got to shift back here 1. That's interesting. Let's use a different color now. What about purple? There we go, purple. Okay, so that's it. So originally our parent function crossed through here, And it came up like that. But now we're going to go ahead and go up one and then shift back one. And so since we're usually here, we're going to go up one and back one. That should be here. So let's go ahead and check our graph. So I think it's going to come along here now, as -1 will be the new asymptote. And then it should cross here. Whoa, it doesn't go down like that though. But it'll keep on carrying upwards, just at a very, very slow rate is what it'll do there. So it's going to carry on. Why does it keep doing that? Stop going down, you little. Close. Make sure you have your eraser. Okay, close enough. Okay, so let's try that now on Desmos. We're almost done here, you guys. Okay, so for Desmos, here we go. So now we're going to go and delete this one. And then we're going to go inside here. And so now we're going to do an X plus 1. There's your shift. And on the inside, parentheses, close parentheses, plus 1. There it is. So it comes up. Let's see if we can zoom out there a little bit. Nice. So that's -5. So this must be 1. Yep, so it goes along -1. Crosses through on the y-axis, y-intercept of 1, 0. And then carries on up and to the right. A little bit, no, not a little bit faster. Yeah, so it's 7, 8. It still hasn't even crossed up 1 square yet. Cool, but we did that right. Sweet deal. Okay, so there we go. So it is going to carry on upwards. It needs to show that. Eventually at 10 it'll cross. Okay, so there's our logarithm graph. Yeah, Desmos. Okay, so then the other thing we want to show you is what if you do have a base of that's not 10, like a base 3, for example. And so this isn't a homework problem. Again, your homework problems are for you to try. There's only 6 of them. Awesome. There's your homework problems. And so we'll kind of discuss this one too, because that's a little bit different. But we'll take a look at base 3 right now. And so a base 3, let's take a look there and how we do that. So if you were doing the graphing calculator, the base 3 would be like this, okay? I'll show that to you. So you go to the math button. You go to the math button and you go all the way down to the bottom. And so after you get to option 9, you'll start getting letters. And so it's actually called log base. It's option A. And so when you click on log base, then you can actually type in that 3. Nice. And then you can type in x plus 6 or whatever goes there. In this case, that's what we're doing, and a plus 2. So log base 3 is going to be, let's see, so it's a right, no, opposite of 6, so left 6, up 2. But let's actually take a look what the base does compared to the base 10. So a base 3 is going to be shifted way over here. So that means I'm definitely going to have to zoom 6 to do our 10 by 10 graph. There it is. Okay, so it looks like it probably increases a bit faster. Not much, but increases a bit faster there. So at 0 and 3.6 is where it crosses. And then 1, 2, 3, 4, 5, 6. And that's because of this guy right here. So we're going to go left 6, up 2, and then we also have the base 3. So that means left 6 is going to be here. And then if you plug in a 0, you get log base 3, 8. And so log base 3, 8 is 3.6. So that goes right here. If you're doing these by hand, you'd have to really think about that, wouldn't you? Log base 3, plug in 0 for x. So then you actually get a log base 3, 6, and then plus 2. So what is log base 3, 6? Well, 3 to the something power equals 6. Well, 3 squared is 9. That'd be too big. So it's like, I think it's like 3 to the 1.6 or something like that. Equals 6. Let's try that out. So really doing it by hand, this could be really tricky. I'd have to guess and check to get that 1.6. And so that's not right. But it'd probably be like, getting close. 1.65. That's a bit too high. 1.64. But just using our graphing calculator is definitely a lot easier. Let me plug in. Lost power there for a second. Wonder why my computers went dim. Okay, so if we go to our graph though and we push trace, we see that it's 3.63. Right? 3.63. And so 3 to the 1.63 gives us approximately 6. And so, awesome. So that's what log base 3 6 equals. So log base 3 6 is whatever this is. And so that's 1.63. Then you go 1.63 plus 2. So that would be 3.63, which we're just going to put here. Okay, so that was kind of, don't do it by hand. Use your calculator. Use Desmos. Okay, awesome. In fact, we'll use Desmos now just to show you where it is. But it's just going to come across like that. And then as we scroll to the right, let's see how fast it's increasing. So as we get to 4, 5, 6, 7, so at about 8, it's going to be 4.4. So it is increasing a little bit faster than our base 10. So that's interesting. So here it is increasing. Slowly increasing. Ooh, that was good, Newbold. Thanks. That was not too bad. Okay, so again, how do we do it with Desmos now? For those of you who don't have a graphing calculator. So again, with Desmos, you have to hit the keyboard. Once you go to Desmos calculator, you have to hit the keyboard. You go to functions. You go to miscellaneous, not trig. Ooh, you missed trig, don't you? Go to miscellaneous, and then it's log A is what you're going to use there. Do you see that log A button? So then you can put in a base 3. Nice, nice. And then do a right arrow. And then you can do your x plus 6. Nice. And then right arrow. And then you can do your plus 2, or whatever the problem asks you to do. Nice. Okay, so you can see here that, there it is. So you can push plus or minus to zoom in, or you can hold down the CTRL button on your keyboard in the bottom left of your keyboard, control. And you can scroll with your mouse to zoom in and zoom out. And so, we do need to show that it goes down, continues downward, and then up and to the right, and about 4 and a bit, at 8 there. Cool. So then this does continue downward. So made a little bit of mistake there. You did so good though, I know, still. Okay, so there we go. Okay, so there's our graph there, beautiful. Oh no. Oh no. Oh, stop it, Newbold. You're killing me. Oh well. Okay, so homework problems. So again, number 1, what would that look like? Well, we just talked about it. So we'll let you try that easier one. Number 2, again, instead of going to the left 2, because it's negative 2, it's actually going to be right 2. Right? So it's going to be right 2, and then what do we do with that negative 4? And that's going to be a down 4. What are you shifting left and down? This is problem number 2 in your homework. And so remember that your graph originally was at this point 1, 0. Right? So that's really the shifting point. So this was the parent function. So we'll do it with dash marks there if you want. So the parent function came along the y-axis, if you remember. It crossed through here and then carried on like that. Okay? And then let's do a solid line now. And so to go right 2, because that's what that negative 2 means, to go right 2 from here, you'd go 1 to here, and then you'd go down 4, so 1, 2, 3, 4. Nice. Okay, so that means that this also goes right 2, and so that means you're going to come along here, and you're going to go like that. And there's your answer to number 2. So find that matching graph. Is it A, B, C, D, or F? E or F? So again, just to show you how that shifted from this point, from the x-intercept is where you want to do your shifting. And so again, it went right 1, 2, And then it went down 1, 2, 3, 4. You see it? So that's what we're shifting, is that x-intercept there. And don't forget that that's also a arrow there that I didn't do. Sorry about that. So there's a little arrow there too. Cool. All right, awesome. So go ahead and do those ones, and then come look at my next video on word problems. Oh yeah, what does the 1/3 even do? And so let's just take a look there real quick on Desmos. So then, what if we changed our base instead of 3? What if we changed it to 1 divided by 3? What would that do? Well, that would do nothing because that freaked us out. I think you have to use parentheses for that, maybe. Let's see. There we go. Maybe. Why is it doing so many? Did that work? Let's see if that worked. Okay, so let's see. What the heck does 1/3 do? I don't even see it anywhere. So I haven't done this before with the calculator, but we're figuring this out. Okay, so let's try the base again. Might have to start over here. Let's try to do 1/3. 1/3 is 0.33333, so you could even do that if you're using Desmos and you run into problems. So again, functions, you're going to go to miscellaneous, you're going to go to log, and this time we're going to do 1 divided by 3 if it lets us. I don't know, I don't think it's letting us, but we'll try. And then let's just do x to see what it does. There we go. And it doesn't like it. Log requires an argument. For example, try that. This is interesting. So I'm guessing if we just do 0.333, because that's what 1/3 actually is. So again, function, there we go. So if you're doing Desmos, do the decimal there, and I think that could help a lot. That's just a quick solve. And there it is. Okay, so then log 1/3 of x is actually going downward, like decaying, not exponentially, not growing. It's actually now decaying. That's interesting. So you'll see one of those on the homework. Now you know what it is, right? The only one's going down, and decaying matches up with your log 1/3. So if you're using your graphing calculator, you go to y equals again, and then instead of 3 down there, let's see, I bet our graphing calculator will do it. So 1 divided by 3, there you go. So our graphing calculator will actually do it. And as you can see, it is decreasing. So that's what decay is. Alright, thanks for watching All About Graphing Logarithms. You're the best. Peace out. Don't forget to Star Wars. May the 4th with you is coming up. Star Wars. Bum 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 bum. See ya.